Hi guys, once again I am here to discuss about electric potential and potential difference. Even within this topic we will also learn about electric potential for a system of charges and electric potential for an electric dipole and the relation between electric field and electric potential. So before to start this topic, let me say about conservative force. What is this conservative force? In class 11 we have learned this thing. Conservative force are those force for which the work done is independent of the path followed in between 2 points. Means if we consider 2 points A and this point B, and suppose this is observing point O, therefore this is RA and this point is suppose RB. If the work done by a force is only depends upon this RA and RB but independent of this path length, means in which way it is moving, that is independent, then we can say that force must be a conservative force. Now why we are saying this conservative force within this topic? Actually we are dealing with electrostatic force, as this electrostatic force is only depends upon this position, means work done by the electrostatic force is only depends upon this position but independent of this path. That's why we are dealing explaining this conservative force within this topic only. Okay, so you have to remember electrostatic force is a conservative force. Now let me come to the main topic, potential and potential difference. So we will start with potential difference. Potential difference. What is this potential difference, sir? Potential difference. Listen. Electrostatic potential difference in between 2 points, suppose A and B, in between two points A and B is defined as the amount of work done per unit test charge to bring it from one point to another point, means from A to point B. So again I am saying with a diagram, let us assume this is the diagram. With that, this is origin, and within this origin a big plus Q charge is situated, and we consider 2 points, one is A and another point is B. Let we have to find out potential difference between these 2 points. Suppose this potential at this point is VA and potential at this point VB, then according to the definition, this potential difference VB minus VA is equal to the work done to bring a unit positive charge from point A to point B per unit that particular charge, means per unit positive test charge Q naught, means we are bringing a charge Q naught from point A to B. Then how much work done we will do? That work done by this charge will give us the potential difference VB minus VA. Okay, now if we want to bring this Q naught charge along this line, then what will happen? Of course, the first case we can say there must be an electric field. Now let us consider this point. Now if we consider this point as a P, then electric field for this point will be along this direction, of course, because it's a positive charge and electric field will be radially outward. Therefore electric field is along this direction and we want to bring it along this direction. Let us consider this point as capital Q and this distance is dl. This distance is dl. Now if anyone want to bring or want to move this Q naught charge from the point of P to the point of Q, then one force will experience by this charge which will directed towards this electric field. So we have to minimize this force. So the force along this direction will be Q naught E. There is no problem. I hope you all know these things. Now we have to minimize this force. So the force what actually we have to apply, that should be neutralize this force. Therefore the force must be, what we will apply, that force must be minus Q naught E. So for for bring for this q naught e, we have to apply minus q naught e. Therefore, work done to bring a charge from point A to point B, what force we have to apply? Minus q naught e. Therefore, this work done WAB by q naught must be F dot S AB vector by q naught, means from A to point B. Now let's find out this work done first. WAB by q naught. We want to find out these things, WAB by q naught. So this, to find out this WAB by q naught, we have to consider a small area length. Let us assume this PQ length as a dl. Therefore, work done to bring this q naught charge from point P to point Q is nothing but dw. So, for dl length, work done is dw, and that dw equal to force dot dl vector. Now this force also we can write q naught e, and that force I told you minus q naught e dot dl vector. Now what about this e dl? As it is e dl, so we have to find out this angle. So let us assume this angle as theta. Therefore, minus q naught e dl cos theta. As it is e dl cos theta, so e we can write as 1 by 4 pi epsilon naught q by distance square. Now let us assume this distance is nothing but r. This distance is r, therefore q by r square. Of course, this q must be this q, means source charge. And dl cos theta, look at this please, this dl cos theta. Here is theta, this is dl, but force is along this direction. Here is r square. If we want to integrate it, then we have to consider this dl in the form of dr. So let from this point draw one perpendicular. Let us assume this is the perpendicular 90 degree. Therefore, cos theta equal to base by hypotenuse. So base means from P, let us assume this is n, P n by hypotenuse. Hypotenuse is this dl. Therefore, Pn equal to dl of cos theta. Now dl cos theta is Pn. Let assume this Pn is nothing but dr. dr equal to dl of cos theta. So in place of dl cos theta, we consider as dr. So this is the work done for the point P to Q, but we want to find out from A to point B. So total work done will be from A to B of dw equal to minus q naught by 4 pi epsilon naught q by r square of dr. So integration. Now integral of dw is wab by q naught equal to minus q by 4 pi epsilon naught within bracket minus 1 by r. I hope you all know how to integrate it. and this point must be from RA to point RB, means from RA to RB we are integrating this. Now this minus and this minus will be positive, therefore it will be q by 4 pi epsilon naught within bracket the upper limit means 1 by RB minus of 1 by RA. This is WAB by Q naught, and this WAB by Q naught is also written as VB minus VA, means the potential difference. So VB minus VA. So this is the equation for the potential difference between two points. So the main formula we have got for the potential difference is nothing but VB minus VA equal to Q by 4 pi epsilon naught within bracket 1 by RB minus 1 by RA. These two are the position vector. Okay, now let's come to the point of potential. What does this mean? Potential. Let us assume this is a positive charge and we want to find out potential at this point P. Then what will be the definition? Actually, according to the definition, electric potential at a point inside an electric field is defined as the amount of work done per unit positive test charge to bring it from infinity to that point. So consider this point is situated at a distance of r. Simple. Now this point is B point, suppose P point, and this point is suppose A point. Now according to the formula VB minus VA equal to Q by 4 pi epsilon naught within bracket 1 by RB minus 1 by RA. This is the formula. Now potential means it is the work done to bring a unit positive test charge from infinity to that point. So according to this formula, potential at a point of P, VB minus VA, as nothing but potential VP equal to Q by 4 pi epsilon naught within bracket 1 by RB. RB means position of the final point. So here position of the final point is P, and which is denoted by a term of R. So RB we can write in the form of R minus 1 by initial point, means from where we are bringing the charge. Now here we are bringing the charge from infinity, so 1 by infinity. Therefore it will be Q by 4 pi epsilon naught into 1 by R. So 1 by 4 pi epsilon naught Q by R, this is the equation for electric potential. So what is the difference between potential and potential difference? Potential means to bring a charge from infinity to a finite point, means here P. And potential difference between 2 points is nothing but the work done per unit test charge to bring from one point to another point. Okay, now one more thing I would like to say. Electric field E equal to 1 by 4 pi epsilon naught Q by R square. Electric potential V is 1 by 4 pi epsilon naught Q by R. So what will be the graphical representation of these two? If we want to draw a graph and it is R, then this one will be for E and this one will be for B. Remember that. So let's proceed with the next. Electric potential is a scalar quantity or vector quantity. So it is a scalar quantity. So in this case, you have to remember one thing. So whenever you will take V is 1 by 4 pi epsilon naught Q by R. So this Q, if it is for positive charge, then this charge will be plus, and if it is for negative, then we have to put as a negative, means minus. Okay. Now, potential for a system of charges. Very simple. If we consider this point O and a system containing four charges, suppose Q1, Q2, Q3, Q4, which is situated at a distance of R1, R2, R3 and R4, then total potential at a point of O will be 1 by 4 pi epsilon naught Q1 by R1 plus 1 by 4 pi epsilon naught Q2 by R2, like this way 1 by 4 pi epsilon naught Q4 by R4. If it is for n, then it will be Qn by Rn. Therefore, this 1 we can write as 1 by 4 pi epsilon naught summation of I equal to 1 to n Qi by Ri. Okay. And if any one of this is negative, then we have to put negative. And suppose Q4 is negative, then we have to place here minus sign. Means 1 by 4 pi epsilon naught minus Q4 over R4. That's all only. Now what is the unit of electric potential? Unit. Electric potential unit is volt. I hope you will know from class 10. And what is the definition of 1 volt? 1 volt is equal to 1 joule per 1 coulomb. That's all. And how we can define this thing, that thing also we know. So no need to explain all these things. Okay. Now the next part, electric potential due to a dipole. So let us consider, here is a dipole plus Q charge minus Q charge, midpoint, suppose this is A and this one is also A. You can consider L also, there is no problem. Now the observing point is here, suppose this point P. Therefore this OP distance is R. Now this point is A, this point is B. This is AP and of course this point is BP. Let this angle is theta. This angle is theta. Therefore potential at point P, if it is V, then this V must be equal to VA plus VB. Means the potential for the point of A and the potential for the point of B. Now potential for the point of A will be 1 by 4 pi epsilon naught positive Q. So Q by A P plus 1 by 4 pi epsilon naught minus Q by B P. Therefore this thing also we can write as 1 by 4 pi epsilon naught, Q is also common, 1 by A P minus 1 by B P. Now how to find out this AP and BP? That's a problem because we know only this A and this R. So from class 10 there were one theory, means as this dipole is very small, even class 11 maths also we can say, if we extend this things, and if this angle is very small, as because this dipole is small, so if we draw a normal from this point to the extended part of this OP region, let us consider this is M, then this AP will tends to MP. Okay, means we consider these two lines is same, means this angle is very small. Now MP equal to, we can write this R plus OM. R plus OM. Now how to find out this OM? Look at this. If this is theta, then this one is also theta. Now cos theta equal to base by hypotenuse. Now what about this base? Base is nothing but this one, OM, by hypotenuse is nothing but this A. Therefore OM equal to A cos theta. Therefore PM we can write R plus A cos theta. Now you may feel trouble to solve these things. Again recheck it. We draw normal is here, means if we cut it and draw this triangle here, then normal is here, means normal is this point. This normal means this point must be M and this point must be O. Of course then this point will be A. Therefore OM is nothing but base and this OA is nothing but A. Look at this. This triangle is just looking like this. Okay. So R plus A cos theta. Like the same way, we can also write this BP. If we draw a perpendicular here, let us assume this is N. Therefore, BP is tends to P N and that equal to R minus A cos theta. You can solve it by your own, I hope. Therefore, this one will be Q by 4 pi epsilon naught 1 by AP, that is equal to 1 by R plus A cos theta minus 1 by R minus A cos theta. Therefore, Q by 4 pi epsilon naught within this R square minus A square cos square theta, and here it will be R minus A cos theta minus R minus A cos theta. Therefore plus R minus R cancel out, so it will be minus 2QA cos theta by R square minus A square of cos square theta. Now 2QA is nothing but P, therefore P cos theta by R square minus A square of cos square theta. Okay. Now this P cos theta by R square minus A square of cos square theta. Now if anyone want to find out electric potential for this electric dipole, then he can easily find out this. How? Suppose this is the dipole, and according to our dipole, this one is plus Q, this one is minus Q, means here this one is plus Q and this one is minus Q, and this point is O. We consider P here and that angle was theta. So if we consider this point, means the axial point, then this angle is actually becoming 0. So for axial line towards negative Q, means minus Q, then theta is equal to 0 degree, and hence potential V will be minus P cos 0 is 1 by r square minus a square. Even if r greater than a, therefore it will be, oh sorry, one thing here, 4 pi epsilon naught is there, we missed this term, 4 pi epsilon naught, so 4 pi epsilon naught, so it will be minus p by 4 pi epsilon naught of r square only. Now if we consider the point along this direction, then the angle will change to theta to actually 180 degree. So the second case, in between this towards plus q, theta will be 180 degree, and hence V will be minus P cos 180 degree, cos 180 minus 1, so plus P by 4 pi epsilon naught of r square minus a square. And when we consider r greater than 1, at that time r greater than a, at that time V will change to P by 4 pi epsilon naught of r square minus a square. Okay. Now the last topic, relation between E and V. So for that, let us assume one diagram in which at the point of O there is a source charge plus Q, two different points, one is P and another point is suppose Q. Okay, now as this point is plus Q, we want to bring a charge from this point to this point, hence one electrostatic force will be applied along this direction, which will move this charge from point P to point Q, but we want to bring this charge from point Q to point P, therefore force will be minus Q naught E. In the same way, let us assume this, in between this a small length dl. At a point of P, potential Vp we consider as V plus dV, and at a point of Q, Vq is nothing but V. Of course, as this point is near, so it will be in higher potential and this point will be in lower potential compared to this P. So V plus dV and V. Therefore, potential difference is Vp minus Vq equal to V plus dV minus V equal to work done per charge, that is equal to Q naught E dot dl. Therefore Q naught E dot dl, here this one minus Q naught E and this one is dl vector. So Q naught will be cancelled out. This will lead to only dV, and E dot dl minus E dl of cos 180 degree. Therefore dV equal to E dl, because electric field is along this direction and we want to bring the charge along this direction. So dl is along this direction and QE is along this direction. So that's why cos 180 degree. Therefore this minus will be plus, dV equal to E dl. Now look at this. This is dl. This length is actually reducing. Means if we consider r, then this one will be r minus dr. So dl is nothing but minus dr. dl is nothing but minus dr. Therefore dv equal to e of minus dr. Therefore e equal to minus dv dr. Okay, so electric field is the negative gradient of potential. That's all for today. In next class, we will proceed with some numerical based on this. Thank you. Have a great day.